Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadeem Khan and I am a lecturer in the Institute of Computing, Guwahati University of Science and Technology. Today we will take lecture number 13 of the subject of object-oriented analysis and design, in which we are going to discuss the state machine diagram of the UML. Dear students, the state machine diagram of the unified modeling language represents the behavior model of the requirements. In the state machine diagram, we have certain different states which represent the main functionalities of the system. So in the state machine diagram, there are multiple states of the system and these states are represented in the runtime of the system. So that's why this is very much important lectures to be followed. This is the discussion agenda. It contains the different topics relevant to the state machine diagrams. It includes state machine diagrams. First of all, we will define what is the state machine diagram. Then we have the uses of the state charts diagrams. The state charts and state machines are two similar things, just the difference of their names. State chart is also used for the state machines. Then we have the difference between state diagrams and the flow charts. Here we will describe the two different techniques and used for the designing behavioral functionality of the system. But these two are two different techniques. Basic components of the state diagrams. So when you are going to plot the state diagrams, then you should be aware what are the basic components of the state machine diagrams. And step to draw state machine diagrams. Different steps used to draw the state machine diagrams and examples of the state machine diagrams. And at the end we have also some references of the books that will be useful for you to study about the UML. Now, what is the state machine diagrams? As its name indicates, state machine diagram is diagrammatical representation of the behavior of the systems in which different functionalities are represented to the states. There may be one or more states in the state machine diagrams. And the state shows that when the system will be executed, then what should be the state of the system at that particular unit of time. So state machine diagram representing the behavior diagrams. The behavior diagram, as its name indicates, means that it represents the functionalities of the system, and that represents the discrete behavior as a part of the designated system through the finite state transitions. So in the state machine diagram, we have the set of the states, and that states in fact represents different transitions of the system when that system will be implemented in our system. So the state machine diagrams contains multiple set of the states, and each and every states represent the system functionalities. State machine diagram can be expressed through the protocol part of the system. The protocol part of the system means that it represents the functionalities of the system. That this machine is in fact used as a protocol for representing the system functionalities. For example, we can say that it currently the state of the project is on the login states, and after the login you can access the main functionalities of the front end of the project, and then from the front end you can perform different states and different functionalities of the system. For example, you can search the records in the system, or you can insert the new records in the system. Also, you can delete the existing ones or update this existing records in the system. So these are different sort of the states through which we can represent the system functionalities. Now in UML 2.4, which is the standards UMLs, currently we are using the 2.4 version of the UML, and 2.5 is still in fact coming with, in the new feature, in the upcoming features. So there are two types of the state machine diagram. One is called the behavioral state machine diagram, and another one is called the protocol state machine diagram. will provide you the differentiation between the behavioral state machine diagram and the protocol state machine diagram in the meanwhile. But the behavioral state machine diagram is a subclass of the protocol state machine diagram. That means that protocol state machine diagram represents the higher level functionalities, means that this behavior state machine diagram is a such part of the protocol state machine diagram in which the functions are represented in the form of the verb in the behavior state machine diagram. But in the protocol state machine diagram, all the functions are represented as a label. Now, in upcoming slides, we will provide you two different examples of the behavioral state machine diagram and the protocol state machine diagram. Now, look at this example. This is the example of the behavioral state machine diagram. That here we have firing systems which can fire a gun. So here there are four different states: calibrate, scanning, acquire target, and the fire state. So in this automatic fire guns, we have calibrate states first of all. In the calibrate states, the sensors will be used to detect the target. Means that here the sensors will in fact identify the distance of the targets or the particular targets on the ground or as well as on the air. And the next is the scanning phase. In the scanning state, we have the gun that scans the sky for radar signature for the particular enemy aircraft. If the aircraft is on the sky, then the radar will detect the particular aircraft from the view provided. So here the scanning will scan the throughout the image, which will be in fact be used for detecting the target. And the next state is the acquired target. Here the automated gun will be used to activate the target tracking softwares. So here certain softwares will detect the target from the scan image, and that image will be provided as a input, and the image will be provided from the radar system, and then the target will be identified, means that here the target will be acquired. After acquiring the target, the anti-air gunfire system will open a fire using a certain cannon. So using a certain cannon, the fire will be fired. So here the final state is the fire. And after firing, again the system will go to the scanning state. Means that if there are multiple targets or if the position of the target is changing, then again scanning will be required, and again the target will be acquired, and again the new fire will be fired here. So in this behavior state machine diagram, you can see that all the state represents the behavior of the system. So the states are representing main functionalities of the system. For example, calibrate, scanning, acquired target, and the fire. You can see that here we are in fact obtaining an idea that all these words inside of these states are representing the certain action. Like fire is one of the action, acquire target is another action, similarly scanning is another action, and calibrate is also an action. So all these states are representing certain actions. That is called the behavior state machine diagram, because each functionalities are represented here in form of the action. The next is the example of the protocol state machine diagram. You can see that there we have the drink vending machine example, and when you insert a certain coins inside of this drink vending machine, then you will be able to draw certain drinks from this machine. First of all, we have the off state. After off states, the system can be ready on the ready states. Now you can see that from the off to on ready we have certain line here, that is the directed lines. Means that from off we can go to the on ready, but we cannot go back from on ready to the off states. And on here on this arrow we have certain labels like action, machine turns on, and again there is another actions that machine releases soda. After on ready states, then on dispensed state will be called here. Means that after ready you can in fact draw certain drinks from the machine, so the drink will be dispensed on that particular dryer. So here on dispensed state is called, and after this on dispensed states, then the waiting states will be called. Means that the system will go back to the waiting states, and from the waiting the system can go back to the off states. Now, the difference between the behavioral state machine diagram and protocol state machine diagram is that one, that on the behavioral state machine diagram, you can see the action are the states in the form of the verb. But here you can see that off, on ready, on dispense, waiting. So all these actions are representing in a form of certain labels where already these actions has been taken. But if I go back to this, you can see that collaborate, scanning, acquire, target, and fire. These are certain action in the form of the verb. But here, off, on, ready, on, intense, and waiting, these are representing the state of the actions only. Means that the actions are not performed, but just they represent certain actions. So that is called protocol state machine diagram, and it is the difference between protocol and behavioral state machine diagram. Now, there is the important use of the state diagrams. So, first we use the state machine diagrams for representing certain events which are used for changing the states. But we will perform certain actions or we will not perform certain actions. Also, these are used to model the dynamic behavior of the system. Dynamic means it run times the behavior of the system, that when the functions will be called, that will represented as a form of the runtime. To understand the actions or reaction of the object classes to internal or external stimuli. When certain external or internal stimuli means that the events arises, then the actions will be changed. Means that the state of the state machine diagram will be changed when certain internal or external events are raised. Now, what is the difference between state machine and flowcharts? Mostly you have also used these flowcharts for representing the logic of the programs. We also represent the state diagram to represent the logic of the program, but there is a difference between state machine and the flowchart. Now, as its name indicates, the state machine provides the changes in the state of the class, but it doesn't represent the process or commands which causes these changes. Means that there is no certain sequence in the state machine diagram unlike the flowcharts, but here all the states are used as the actions. While in the flowchart diagram, we in fact provides the process or a commands of certain execution of the functions of that particular object belonging to that particular class. So in the flow charts, we have certain sequence, and exactly like in the process or in the commands, we have certain sequence. Like waterfall model is a process model. You can see that there are multiple activities in the process of waterfall model, which are in fact executed through certain sequence. So flowcharts contain certain sequence as like the processes are commands, but unlike state machine have no certain sequence there. That is the main difference between the state machine and flowchart. Now, there are different components used for drawing the state machine diagrams. We will draw the state machine diagram in upcoming lectures, but here we are providing you the brief idea about the state machine diagrams and with the different examples. So, First component of the state machine diagram is called the initial state, and that is represented through the filled black circles, and that is called the initial states are a class of the system. The next component is called transition. From one state we can perform the transition to another state. Here we will use the solid arrow lines to present certain transition, and that transition is also called the event here. Here the arrow is labeled with the event which provides the changes in the states. That, for example, from a login states we go to the main window, then here we will be labeled with a certain events that passwords are and username and passwords provided, then that will be the events which will be changed straight from the login to the main window. Another state is in fact the state itself, that the component is required which represents certain functionality is called the states, and state is represented with a round rectangle to represent the state. A state represents the condition of the certain circumstances of particular object of a class at that point when the particular state is executing. So the state represents a behavior or functionalities of the system. Another important component of a state chart or state machine diagram is called the fork. The fork is used when we have a certain transition which is in fact triggered in the form of the branch or branches. If there are multiple states, then there will be more than two branches. If there are two states, so that's there will be two substates or the arrow lines. So fork is representing the rounded solid rectangle, that is the rounded solid rectangles, and it represents the outgoing arrows towards the newly created certain states from the old one. This is the first states or initial states. Then we have two or more than two states, so there will be the fork. We use force notation to represent a states which is splits into two or more concurrent states, and these are parallel or concurrent states to be executed. Unlike before, we have the joint states. In the joint states, we are using the solid rectangular bar which represents the joints of two states. Means that there are two or more than two states are joints, and then after joining the another final or the one state is executing. We use the join notation when two or more states are concurrently converged into one or one state's occurrence of an event or certain number of events. Another one is called self-transition. It means that when a state performs the transition to itself, that is called self-states. In simple words, the states calling itself is called self-transition. So there might be certain scenarios when one state calls itself or one object calls itself upon no changes in the occurrence of the events. So we use a certain self transition to represent certain such cases. Another important component of the state chart is called the composite states. Here we use certain round rectangle to represent a composite states. So it represents the states with internal activity using a composite states. Means that if there are multiple states inside of this composite set, so all these substates were represented through the composite states. And this is the final states, which is in fact filled circles within a circle notation represents final states of the state machine diagrams. You can see the filled circles inside of the empty circles, and it is the final state of the state machine diagram. Now, what are different steps used to draw the state machine diagram? First of all, we need to identify initial states and the final states where the state machine will be terminated. and then we will identify all the possible states in between the initials and the terminating states. So in which the objects can be exist, all the boundary corresponding to different attributes guides us is to identify the all different states of the state machine diagram. And the third one is to label all the events which will be triggered when these particular states will be called. So these events represents the different labels on the arrow lines which connects two or more than two states here. This is the example of the state machine diagram. It is in fact used to verify the pin code when the card is swapped. So first of all we have the starting states, and this is the ending state where the user will be successfully identified. In the start states, when the card is swiped or card is inserted inside of the card scanning machines, then here we have the card swiped transitions, and the waiting for the pin states will be called here, means that the system will wait for the pin code provided by the customers. So there you can see there is the bi-directional line. So means that after when the pin code is entered into the card reader machine, then the pin code verification will be called. And if there is certain problems, then the pin code will, if for example the pin code is wrong, then the pin code rejected message will be provided, and again the system will wait for the entering of the pin code. And if correct pin code is entered, then the system will go into the pin identification authentication steps, and finally the user identifications will be provided here. So this is the simple example of the state machine diagram. This one is another state machine diagram for online order systems. When we want to order some products through the internet, then we have certain set of states to be used, and that is represented here by this state machine diagram. So first, the order will be received by the online ordering system from the customers, but that order will be the unprocessed order. So here the order will be checked. If there are any other reasons to reject the orders, so the order will be checked and reject states will be called here. So here rejected order states will be called here, and the transition is to check the orders. So straightforward, the reject states order will be called here. Now there will be due to some reasons to reject the order. For example, if there are no price certain amount in your credit cards, then the orders will be rejected. And also if the current system has no stock for that order which has been placed by the customers, so then the order can also be rejected. So the order will be rejected and the state will be finished, that is the terminating states. Now if the order is still in the unprocessed orders and then the order is accepted, then accept order state will be called here. And after accepting the orders, so there will be two parallel states will be called, that is the pending orders or fulfilled orders. Means that the order will be pending due to some reasons, that for example if some items are not available to be processed, then the order will be incomplete and it will be in the pending states. But if all the items are available, so some items are available, then process or deliver the order, then fulfill order states will be called here. And then after fulfilling orders, then the order will be dispatched, and then the final terminating states will be called here. And if the order is accepted and some items are not available, then the order will be pending, and after the availability of the items, when all items are available and then the new supply will be provided, then fulfilled order states will be called here, and then the state machine will be finished here. So that is the state diagram for online order system, where we have 5 different states and start states and one ending states. So all these are in fact the 7 different states with us here. Another example of the state machine diagram is here to initiate the cooling systems of a certain room. When we have too hot temperature, then the system will be, in fact, the cooling system will be called here. And if you have too cold temperature, then the heating system will be called here. Now this is an examples that have in fact a substrate machine diagrams here. You can see that inside of this state there are two substrates, and these two substrates also have the initial states. So when these states will be completed or it will be processed, then the cooling state will be called here. Now we are starting it from the very first starts. That for example from here this state machine is starting. That is, first of all we have the idle states. Now, from the idle state, you can see that directly it can go down to the shutdown state due to certain reasons or due to certain problem. For example, if the power failure problem is, if there is, then the system will be shut down. Now, from the idle states, this is called the states. Then we can go to the cooling states. We can also go to the heating states. It depends on the room temperature. If the room temperature is too hot, means that if the room temperature is too hot, then the system goes towards the cooling states, means that the cooling state will be called here. So there is in fact a facility in nowadays uh, systems that when the temperature is too much hot, then the cooling states will be called here, means that the cooling states will be initiated. So after cooling states, again the system may go to the idle states. Now from the idle states, if the temperature becomes too much cold, so then the heating states will be called here. And in a heating state there are two substates. So the start states of the heating state is this, and then activating, the heating state will be activated, and then the heating state will become active, means it will start working. So after heating states, you will provide here the heating levels, because this is the substates of overall this state machine diagram. So from the heating states, then the cooling states can be called here. For example, if there is too hot temperatures, exactly this function is called here, too hot and too hot. Desired temperature and desired temperature, means that the same function is calling here, and this function is in fact providing the transition from the heating to the cooling states. So again cooling state will be activated, and from the heating again, if attempts parameter is provided, then the idle states may also be called here. So that is in fact the initial state, that are the idle states. So from the idle again, if the temperature becomes too hot, then the cooling states may be called here. And from the cooling, if temperature becomes too cold, then the heating state will be called here. And these are the nested states, means that these are in fact residing in a one heating state. So, and these are the part of the heating state, and these are substates of the heating states. So that is in fact state machine examples where we have provided a substates, a sub state machine diagram inside of the state one state machine diagram here. Now this is another example of the state machine diagram where we will provide a searching and tracking systems here. Here we have the start states, that is the start of the state machine diagram. Then the system go to the idle states. So it will remains in the idle states until if it has been triggered or it has been interacted. And after interactions, if there is noise, means that if there is noise, then the target will be searching. In the searching, the system will search the target, because due to certain noise, if there's no clear target, then the searching state will be called here. It is in fact try a target tracking system. Now, if there is no nice, then directly tracking will be called here. Means that target at p is thread to dot add target. That means that these two functions are calling. Then, due to these two events, the tracking states will be called here. And after tracking, the engaging system will be called. Means that the system will engage the target, or it will perform certain action over the target, that it will hit the target. So after tracking, the engaging system will be called here. And if there is noise, then after searching, means that when searching state will be completed, then the tracking state will be called here. Means that it will track the target. And after tracking, the engaging system will be called here. By engaging, we means that it will hit the target, or it will fire over the target. And after firing, again the system will be in fact in the pending states. Now you can add substates here as well. For example, due to in the engaging, if the target is changing, then again searching or tracking state may be called here. So this is another state machine diagrams. You can see that here there is the self transition. It will remain idle until and unless it has been interacted. So if there is no interaction of the user with the system, then it will remain in the idle states. So this is the state machine diagram for detecting the target here. Now you can see that in the tracking there will be certain functions, that is entry, exit, new target, do, self test, and set mode target dot acquires. You can see that there means that entry means that set modes, exit means that set mode off track, and on track will be in the entry states and off track will be the exit states. And if there is the new target, then track dot acquire, tracker dot acquire. If the target is changing its place or its positions, then the tracker.acquire function will be called here. And if there is certain activity, do following target. So follow the targets here will be called here. Self test defer means that the test will be deferred here. So this is the example of the state machines here. Dear students, this is the end of the lectures. If you have any questions, you can ask the question through the email. My email is here, m.kadeem@kust.edu.pk. I will wait for your questions and will respond soon as you email me. And I check my email daily, so I will answer you immediately. And this is the reference books for you. If you want to study the UML modeling, no, so you should read this Springer book. It is a standard book of UML, modeling with the UML language, concepts and methods, written by the Rump and Bernhard. So you should read this book, and it is very much easy and standard book of the Springer series. So also, if you have question, you can ask these questions through this email. My email is m.kadeem@kust.edu.pk. I will wait for your question and will respond you soon as soon you provide me your queries. Thank you very much.